So good afternoon and welcome to the lectures for Calculus for Industrial Design. So my name is Martijn Antonissen and normally we would be meeting in a lecture room in Eindhoven, but due to the circumstances we'll have to do it this way. So I'm in my little bit of Eindhoven, which happens to be in Utrecht today, and I'm live streaming to you via YouTube. I have been giving lectures online already, but usually I pre-record them and then make the recordings available via Canvas. So this streaming via YouTube is also for me a new experience, and I hope to learn from you how you like this. Now, today we'll start with a little bit of a course introduction. So what is the setup, and also why is there a calculus course for industrial design? So why do you have to take this course, or why do we teach you this course? So let me go to the slides, and I have made a setup like this so that you can still see me hopefully explaining a little bit more, and I hope it helps for you. Let me know what you think about that. For feedback, please use the chat in YouTube. I'll check that during the break because it is too much to be teaching here. Maybe I'll share with you a little setup, because I've got my computer here, webcam, microphone, I've got a laptop, I've got my iPad. So there is a lot of stuff going on here to be able to present this for you. And I'll check the chat during the break. So I'll be talking roughly for 45 minutes, then we'll have a 15-minute break, and then another 45 minutes today. So first of all, a little bit on who I am. So my name is Martijn Antonissen. I work for Eindhoven University of Technology, and in particular at the Department of Mathematics and Computer Science. You see here my email address, so should you ever want to reach me outside of lecture hours, please send me an email. You can just click the email address. Also at the lower left of all my slides here you can see is my name. If you click that, you can also send me an email. There will be a direct link to sending me an email. Now, I will be talking about the mathematical part of calculus. As you can imagine, this course is being taken by all first year students at Eindhoven University of Technology. So that's more than 2,000 students. There are several versions of calculus. There is a version which is more oriented towards applications. That's variant 1. The industrial design version is variant 1. Also, the students from architecture, bouwkunde in Dutch language, will also be taking this version, but then taught by my colleague Emiel van Berkem. Then many other students, so most of the departments, most of the bachelor programs take variant 2, which is a bit more theoretical. And then there is also variant 3, which is for the students of mathematics and physics, and there is more proofs and more theory in that version. So as you can imagine, there was a lot going on there. There was a whole educational setup with tests going on, the environment on Canvas and so on. As such, this is rather a big operation. If there is any organizational stuff that you need help with, please check this email address. So that's calculusabc@tue.nl. So ABC, that refers to the different versions of calculus. But here is people who do all the organizational stuff. So if you're not sure which tutor group you're in, you cannot find that, do not email me, but email those people. If there is anything about the lectures, anything with mathematics, stuff industrial design specific, you can send me an email. So first, why is there a calculus course for industrial design? Well, there are several reasons for that. So one of them is that we want to school you in systematic problem solving, which is a skill that you won't be using in mathematics only, but that will be beneficial to hopefully all the projects that you will be taking on. Also, we would like to help you in abstract thinking. So can you, if you are given a difficult problem, can you throw away the unimportant details and try to see what is the main characteristic of that problem, which features should be in a model, a simplified version of whatever you're trying to understand, model, simulate, and hopefully calculus will help you there. Also, as you can imagine, many of the projects that you will be taking on, either during your studies or after, will be in teams. In teams not with industrial design people only. Normally you will be working together with electrical engineers, mechanical engineers, mathematicians, people who have studied computer science. If you want to talk with them, if you want to understand each other, you should be speaking the same language. And mathematics is one of those languages that you use to talk about projects. Then you will need the technical skills in your design work. So also for the work that you do in industrial design, you will be needing calculus. And if you're more geared towards the short term, in Q2 there is going to be a physics course, and that's going to use whatever you've seen in calculus. So you will be needing calculus stuff to do the physics course. So a little bit abstract. Very often if you have a real life problem, it is hard to solve it directly. So think of a technical problem that a company like ASML or Philips is dealing with. Now, if it is too difficult to find directly a solution to that, what you can do, what is one of the tools that you have, is to try and model it. So can you capture the problem that you have in terms of mathematics? If you can do that and you find mathematical equations, then there is a whole literature of work that has already been done that can hopefully help you solve your mathematical model. So if you have a solution of this mathematical model, hopefully you can then translate that back and find a solution to your real life solution. So that's in a nutshell a kind of modeling step. And indeed calculus is important for this too. So a little bit more about me. I won't be talking about me all the time, but we'll be sharing quite some hours together. So I would like you to know what I work in. So my field within mathematics, there's different areas there, is the type where you have problems, for instance, from ASML. So what you see here at the lower left is a wafer that ASML produces. Well, ASML produces the machines to make wafers for microprocessors. Or here in the middle, you see an MRI scan of the human brain. And an MRI scanner produces a lot of data, and you would like to translate that into pictures or movies that a doctor understands. Or here, think of the energy transition. The Netherlands is building many wind turbine farms at sea. Where should you build them in the North Sea so that you have a high energy production? And if you place your wind turbines in such a farm, how do you place the turbines in a good way such that they produce a lot of energy? To understand these types of problems, you can model them with mathematical equations. For instance, flow equations, equations that describe how air flows, the ones that you also use for weather forecasting. But those equations are too complicated to solve analytically. You cannot find pen and paper solutions there. So what you can do is try to solve them numerically. So try to find approximations to the solutions using computers. So this is called numerical mathematics. That's kind of the old-fashioned name. These days it's called scientific computing. So I work in the scientific computing group. And the typical questions that we are dealing with is, if we make errors, can we say anything about those errors? Can we say, well, our solution, our numerical approximation is such and so accurate? Also, you can probably imagine that if you invest a lot of computational effort, then you can get a very accurate solution. If you do a very short computation and you get fast results, in that situation, it won't be so accurate. So there is a trade-off that you have to do. If you want to find tomorrow's weather, you can spend 48 hours computing tomorrow's weather, but that's useless. And also, if you do it in 5 minutes, probably it won't be very accurate, and that's also useless. So there is a balance there. If you think about physics, so the way physics traditionally works is that you can write down a theoretical model to describe something like gravity. You can also do experiments, and now you can also do computer simulations, and sometimes that helps. If you want to understand if the seawater level is raised in which part of the Netherlands is going to be flooded, you don't want to do experiments there, but you can do computer simulation. So that's kind of a third discipline. Next to theory and experiments, you can also do numerical experiments, computer simulations. So this is an area that's strong and lively, and it has many applications. For instance, the high-tech industry, think of ASML, weather forecasting, there is a lot going on in health, finance, and so on. So back to calculus now. This is a little bit about where I normally work in, and then you have a little bit of a better understanding. So how does it work? So normally there would be lectures at Eindhoven University, as I already said. These lectures will now be online. So I will be streaming them via YouTube, as we do now. And that is going to be on Monday and Wednesday. So on Monday it's at this time, 2:30, 45 minutes lecturing, 15-minute break in which I will look at the chat room and your questions. And also on Wednesday I will do lecturing, and then at 10:45. And it's going to be the same way, 45 minutes, 15-minute break, 45 minutes. And hopefully that's doable for all of us. If not, let me know. There is also a tutor group meeting. Your tutor group is a smaller group of students. And that is going to be either at 8:45 or 9:45. And you can check Canvas to see which time you're in. And hopefully you'll be invited by your tutor via email. So let's see a little bit more about this tutor group meeting. So you can find it in Canvas, as I already said. I will show you where to find it in a minute when I'm going to give a little live demo of Canvas and where stuff is. The group size is 8 students, and please make sure that you know the name of your tutor. So it's a small group, and you get weekly feedback on your work. So you have to hand in homework, a little bit more about that in a second. And there's also online tests. So you have online practice material. Your tutor can see how well you do there. And you also have online tests. And even if you run a little bit behind and you think, well, I shouldn't go there, please go to your tutor meeting because it's important. And also, if you didn't study it yourself, of course, you should try and keep up with the pace because you will see that it goes quite rapidly. But even if you didn't manage, go to the tutor meeting. It's the most important meeting. Skip my lectures, go to your tutor meeting. So your tutor can answer your questions and also the questions of your fellow students. And you can also learn from that. So even if you didn't have time to prepare yourself, listen in on the questions of your fellow students and the answers of the tutor, and that will also greatly help you. So your tutor will invite you, and it will be a meeting, so a 1-hour meeting via Microsoft Teams. You will get to see a lot of Microsoft Teams in the coming year, I think. And you have to hand in your homework. So there is a list of questions from the book that you should answer. Some of them are in bold, and those are the ones that you should hand in, and your tutor will mark them for you. So you will get comments like, well, this is not entirely correct, or you should be more clear there, and so on. And the deadline is always the Wednesday in week n+1. So this week's questions, you have to hand in next week, Wednesday. So that will be September 9. That's the first deadline for you. As you may already have seen, the book that we use is called Calculus Early Transcendental Functions, and it's the 5th edition, so that's the latest edition. Very often you will hear us refer to it as Smith and Minton, because the original 4 editions of the book were written by those two. And Raffi, the third author here, he is new for the 5th edition. So if you see reference to just Smith and Minton, that explains why. You need the book, so you should get the book or the online version, but you will be needing it. All the theories in there, the questions that we do during tutor hour, your weekly homework, that's also from the book. And what we deal with in this course is parts from chapter 0 until 7 and then chapter 10 a bit. And so we won't be covering the whole book, parts of them, and we'll jump around a little bit through these chapters in a different order. One of the extra bits that I would like to point out is the title of this book. So if you learn anything from the calculus course, it's at least why calculus is called calculus, and then this funny early transcendental functions. If you ask my colleague mathematicians, I wonder how many can tell you what this early refers to, because that's very strange. So calculus, that's not so difficult. So a little bit on the title of the book. This is a little sidestepping, just to make it more fun, hopefully. So calculus is from Latin, and it means a pebble, a little stone, which is what they use to count. So it's a general term for basically the mathematics that immediately follows to a high school mathematics. So most of you will have done wiskunde B, mathematics B or D in high school, and calculus is what comes after, extending on that. Now also, so my fellow mathematicians will be able to tell you what transcendental functions are. So if you think the basic operations in mathematics is plus and minus and times and division, and then there are more complicated functions, as you already know. There is like sine and cosine and tangent and the exponential and the logarithmic function. So those functions are called transcendental functions. So the non-algebraic ones, the ones going further than algebraic operations, that's called transcendental. But then the early bit, well, what it means is very mundane, because what it means is just that the textbook covers these transcendental functions early in the book. So there is like two types of calculus textbooks. The one that treats transcendental functions early and late. So you have textbooks, early transcendental functions, the ones we use, and also late transcendental functions. So now you know why the book is titled like this. So now I can tell that there is 180 people listening to this live stream, which is great. I appreciate it very much. But there is one thing that you should keep in mind, which is a bit of a breakdown of the work for this course. So this course is 5 credits. You probably have already seen that. At university, an academic year is 60 credits, divided into 4 periods. This is Q1, so 15 credits for this quarter. Calculus is one of the 3 courses or projects that you will be taking. So 1/3 of your time every week should be spent on calculus. So 1 credit point has a workload of 28 hours. So in total there is 140 hours. We take 12 hours for preparation and taking the final exam. So that leaves 128 hours. We have 8 weeks of lectures, which means 16 hours per week. So that means that you should be spending 16 hours every week on calculus. Now, we have lectures, which is what we do now, but it's only 4 hours per week. Then there's your tutor group meeting, which is 1 hour. And you see that there's this whole green chunk of 11 hours per week that you should be spending on calculus by yourself. So you will have to spend quite a bit of time trying to solve all the questions, exercises that we put up for you. There is only 5 hours that we fill in, and the rest is going to be self-study. Of course, you can work together with your fellow students, but you will really need to be spending time on it. So, a few tips, if you like. Mathematics is something that you only learn by doing it. So, I will try to explain the concepts here. I will present examples and solve them for you. When I solve them for you, I know how to do it, and I'm going to present it in such a way that hopefully you think with every single step, yeah, that makes sense. That's the way I would do it too. But it's going to be a whole lot different when you're just being presented the problem and have to take these steps yourself. You will, in the beginning at least, not immediately know which way to follow, which path you should take. And to get there, to know that for future problems, you will have to try to solve it yourself. So that's really going to be taking those 11 hours. So you really have to do it. Seeing someone else do it, it's a bit like with ice skating or soccer or whatever. Seeing someone else do it does not learn you how to do it. So that means that you should also try to solve all the exercises yourself. If you look at someone else's solution, it's not going to help you. First try yourself, then look at solutions. Now, that doesn't mean that you have to do everything by yourself. It is really great to be working together with other people. So, for instance, the people in your tutor group, it can be very helpful to work with them because they can give you a pointer. The other important thing is that you should keep up with the weekly program. There is this very cliche example of a train that starts riding and that you have to jump on in time. It is a bit like that. We are going to be covering quite a lot of theory, so try to keep up. If you don't do anything for the first 3 weeks or only do it half, you're going to be in big trouble. In week 5, there's already going to be the midterm test, so you really have to start working from the very beginning. So visit the tutor group. I say here it's compulsory, that's true, attendance is registered, but there's like the carrot and stick principle. These are the sticks, well, for what they're worth, but you really benefit from visiting your tutor group meetings. So you really should be going there. They can really help you, so be there. As I said, if you don't have the hours to spend, skip my lectures, go to the tutor group. So my slides are available before the lectures, and I'm going to do a little rundown on Canvas where you can find all the course information, all the things that I say here in much more detail if you want to know the nitty-gritty. You can find all of that on Canvas, and also my slides are there, so you can watch them. So you can see them in advance and think already about it, and then later here we talk about them. Then a little bit on how can you pass this course, or which hurdles do you need to take. So there's going to be a STAR test, which is going to be this Thursday at 6 o'clock. I have a separate slide on that, but that counts 10% towards your final grade. Then in weeks 2 until 7, so starting next week, there's going to be digital tests. So you go in your web browser to a site, the link is on Canvas. You answer a couple of questions there, and that counts also 10% towards your grade. Then, as I said, in week 5, there is going to be like a small exam, if you like. So it's a bit like the final exam, but then shorter, and only about the first couple of weeks of the course, obviously. And that's also 10%. And then finally, there is the written exam, which is also going to be online. You can either type your answers there, or you can write them on paper and then hand in a photo or a PDF file. You'll get the details when the written exam is getting closer. There is one extra requirement. For the written exam, you need to have a 5.0 by yourself before all this other stuff starts counting. So the written exam is the most important one, and you have to get at least 5.0 there, and then the rest counts. If you score below 5.0, you didn't pass the course. A little bit more on the STAR test, because it's already this Thursday, so that's the 3rd of September, it's at 6 o'clock, and you can find a link in Canvas. I'll point it out in a second. It's going to be multiple choice questions, so here you only have to check A, B, C, or D. There is one correct answer only, so it's not going to be those horrible multiple choice questions where you have multiple correct answers, or where there is an answer like, well, 2 out of 3 are correct. Nothing like that. One correct answer, 3 incorrect ones. It takes 1 hour. You can see Canvas for the link. I will point that out in a second. And to prepare, you can find material in Canvas already. And there is also this website where you can go to. The link is also in Canvas. And in study materials on Canvas, there is also a PDF, algebraic skills, and there is also a Dutch version called rekenvaardigheden, and you can find more information about that. So this is basically the high school mathematics stuff that you already studied in high school. You can have no tools, it's just pen and paper. You can have some scratch paper, but you cannot have a calculator. So no calculator, no graphical calculator, no laptops, no formula sheets, nothing like that. In the meantime, I'm going to answer a couple of questions from the chat in a second. So let me wrap up by saying that Canvas is like the most important website for this course. So this is the link, canvas.tue.nl, and that's the central location. You'll find all the information there. So the detailed study guide, what I just told you, but then in much more detail. You find there an introduction video by Hans Kuipers. So Hans Kuipers, my colleague from mathematics, is the responsible lecturer for all of calculus, so for all 2,000 plus students. And he also made an introduction video with a bit of background, and it's a 20-minute video, and you should watch that first. After my lectures, of course. Then much more you will find, so I'll be posting the link to the YouTube streams. This is my first experience, but I understand that they will be available afterwards too, so I'll post the links there too. My slides are there. There's going to be some extra videos on some of the material. Hans Kuipers also made a couple of videos. You can find video recordings of this course in 2019-2020, so last year. That's recordings from the lecture room at Eindhoven University. It's not me, it's my colleague Emiel van Berkem. So it's the bouwkunde, the architecture version of the course. But if you like, you can see those too. There's links to the digital test, the exercises from the book, and a link to the START test. A little bit more on the digital tests in week 2 until 7. As I said, they are part of your mark. The interesting thing with those, so they are the online tests in this week. They count towards 10% of your final degree. You can ask for new questions there. So the questions have some numbers in there, and they change every time you ask for a new question. So if you answer a question, did it get full marks? You can ask for a new question and then get full marks. So I will also show that in a minute. But for the digital tests, you can score 100%. So if you spend some time there, it's easily score 10. So what I would like to do is now go with you to the Canvas site. So I will show that on the screen. You don't have to change. You can keep watching me, and I will show some of the stuff. Before I do that, there were a couple of questions already. So the 4th edition of the book, so the 5th edition is what we use, the newest version. If you have the 4th edition, you'll find there are very few changes in between there. And also when we list the questions, the homework questions, when it differs between the 4th and the 5th edition, we will point it out and we say, well, this question is this number in the 4th edition. Your homework will be graded for you, so your tutor will grade your homework. The START test does not have proctoring. So the question about extra time. So some students, for instance, when you have dyslexia, you will have some extra time for digital tests. I am not sure if you will automatically get that. So to get that question answered, please send an email to calculusabc@tue.nl. So the general organizational email address, calculusabc@tue.nl. And the tutor group sessions are online, so they will be via Microsoft Teams. And the START test, so students who take this for the second time, there are students who didn't pass it last year and are second or third year students and still have to do it. You have to take the START test again. And the START test is also online, so everything will be online. And these live lectures, they will be saved. I hope, as I said, this is my first experience with YouTube live streaming. I did some experimentation yesterday. I think there was quite a delay there, though it seems to be fine now. But I think that YouTube stores them, and I will, if the link changes, I will make sure that Canvas points to the recording. Okay, so the rest of the questions are also very much to do with Canvas. So I'm going to do a little demo. So this here, hopefully you've already been here. this is the Canvas site. And I can point like this. Let's see, yeah. So here, this blue link at the very top points towards the introduction video. So if you click that, you will see my colleague Hans Kuipers explaining more generally about the calculus lectures for all students and the setup. And as you see, so this course code 2WAB0, so all the courses at Eindhoven University have funny names like that. This is variant 1, so this is the variant 4, as you can see here, BBK, BID. So that's the bachelor, the first one, Bouwkunde, which is Dutch for architecture, urbanism and building sciences. And then there's us, BID, the bachelor industrial design. And then if you scroll down a little bit more, you see here, this bit here, introduction. Let's click it. Introduction. So you see here that we are apparently time slot B. That's my name. Monday, Wednesday, and so on. And here you will see a little bit more detailed what I've just been explaining. So the different tests you have, the different educational forms, and so on. Then if you go here, oops, sorry about that. If you go to the second bit here, study materials, let's click there. Then this already answers someone's question. Here you will find the PDF algebraic skills, or the Dutch version, rekenvaardigheden. And that's basically the mathematics that you had in high school, but condensed to a very short form. So if there is topics that you think, well, I forgot most about that during the summer holiday, check there. That's mostly it. So also there is here a folder extra study material for BID, but I'll just put it on the website. So the weekly pages that we have, I'll get there in a second. I'll put my slides there, like I did for today. Examination, that has a little bit more info on the different forms of exams that we will have here. So start test, midterm, the online test, final exam, all the details. So let's not go into that now. This is also interesting. So it jumps to the start all the time. So here, the manuals, you should also have a look here. So after the lecture today, just go through the Canvas site, look all the information that's there. If you have questions, let me know. But there is a little bit more information. There's a couple of videos from Hans, so how to use Canvas, how to deal with mathematics in your browser. ANS is the system we will be using for submitting homework, so you can make your homework there. LaTeX, I'm not sure if you ever heard about that, but that's like the standard software being used for mathematical typesetting. And you can also use that in ANS to type your homework. If you want to type, you get very nice, beautiful formulas. A little bit on use of Teams and so on. Okay. And teachers, that's just my name and Emil's name. Now here, if you look, so contact, this is the organizational email address. So if you have any questions about organizational details, like what about the extra time during tests, send it to that email address. And here for the weekly activities, so we are time slot B, BID. And if I click here on week 1, like this, then hopefully you have already found that. So here it's basically the outline for the week. So week 1, and the B refers to us, to industrial design. A is architecture, B is industrial design. So what you see here is Monday. So we are having lecturing via YouTube live stream. This is the link that you've all clicked, all 180 of you. My slides are here. So the slides that I just covered, the introduction bit, that's this one. And then the mathematics for week 1 that I will start with in a second. That's also there. And here, this thing is also interesting, because if you click there, let's do that. Then here you can post questions. So as you see, there is only one single question, and that's not really a question, that's just me. So here I say, please note that you can use mathematical notation in your question. So I put just a function here, and you see that it gets formatted really nicely. So if you have mathematics and you put it in between dollar signs, then it will be rendered in a nice way. So there is this little manual that I just pointed out for LaTeX formula formatting. So if you want me to cover something during the lectures, please use this feature. So I'm going back now to online lectures, and this posts your questions before the lecture. It will always be there. So it will be for every lecture, it will be there. And you can use that if you want me to do something, if you want me to answer a certain question. You can also look there and see the questions your fellow students have, and you can upvote and downvote them. So if there is going to be many questions, then this is a way to make sure that the ones with higher priority get dealt with first. The other thing, if you find that cumbersome to typeset these things, if you just write it down, you make a photo and you email it to me, that's also going to be fine. As long as you've got a nice photo and I can easily see that, you can also email me your questions like that. So when it's mathematical questions, that's also one way to do it, okay? So there is the tutor hour, as you can see here. The theory we cover from Smith and Minton. So this week is sections 0.1 and 0.6. So the videos on selected topics of the week. That's videos that I may be making in the coming weeks about certain topics. And also this week points towards videos by Hans Kuipers. They are for all calculus versions. And it's separate topics. And then there's the recordings of live lectures of previous years. So that's last year. And as already pointed out, that's not me. That's my colleague Emiel van Berkem with the Bouwkunde version, the architecture version of the course. For industrial design, there are no recordings yet. So these things will be recorded, what we're doing now, but there are none from last year. Then if you look here, the lectures for week 1 topics are labeled lecture 01B, 01C, and so on. That is, if you go to the recordings of last year, you will see these funny names, and these are the ones that correspond to the week 1 material. Online exercises. So here it is just extra practice exercises. And I will show you the digital test in a second. So I will go to week 2 because then we already have digital tests and show you how that works. So here you find stuff about the STAR test and the link for Thursday. So it's online. On Thursday you click this link and then you can do the test. And this is already for Wednesday, so we're not there yet. One last thing to wrap up is that I would like to show you how these digital questions work. So I'm going back and starting in week 2, so I'm going to go to week 2 here. Starting in week 2, we have the digital test. So week 2 has the same outline, but here there is the online test, and you see the deadline is September 16. So let's click there. And then this looks a bit intimidating, but I just press enter. And you see, I already tried to solve a couple of questions. I didn't do very well because if I have a cross there, it means that I didn't do it correctly. I scored 0 points. So here, for instance, question 10. So you can just click it and then you get a question. So you see, I get the question, write the polynomial x squared plus 6 times x plus 5 as a product of linear factors. So I can click here and then start typing. So I'm going to type this x plus, so probably you recall this. It is something like this, x plus 5 times x plus 1, because if you expand this, you would get x squared plus 6x plus 5. But if I press submit here, you will see that I will get an error message The reason being is that it's almost correct, but you have to put the multiplication sign here. So just the character above 8, the little star, that's times, and it will change into a little dot here because that's the mathematical notation. But if I now submit this, you will see that it's great. But I got only 70 points because I did it wrong in the first time and they had to tell me that. Now what I can do is I click on question 11. That looks horrible because I don't know how to do that. So I go back to question 10. And now you see that I have a different question. So it says now x squared plus 6 times x plus 9. And I am going to write that as x plus 3. And now I would like to do to the power 2. So now I click on this blue bar here. And you see that I get all kinds of interesting mathematical thingies now. So this is how you can do mathematical notation. So I want to have to the power 2. So I'm going to do this. And then I go back. And you see that this x plus 3 here. Oops, can I do that? Oh, that doesn't work. Okay. So I now have to move inside the box. So x plus 3. And then I go up to the power 2. Now let's submit this. Submit. And great, 100 points. So now you see that also here, if I make this a little bit wider, you see that I now have 100 points. So for the online tests, you can score 100%, just ask for a new question. So here also I scored apparently 70 points. I can go back. What is the domain of the function f given by fx is 49 minus x squared? So the requirement, hopefully you recall, we also come to that, is that 49 minus x squared should be larger or equal 0. So that means that x itself should be in between minus 7 and plus 7. So the way you type that is that you want x to be larger or equal minus 7. And now I want a requirement that it's also smaller than 7, and I need this symbol here. So this means and. So the other requirement is that x is smaller equal 7. And let's see if this works out. Submit. Great. So that's how you can do this. So work a little bit with this, and there is also a little guide on how to do that, what mathematical notation to use and how to use it on Canvas. So Canvas is like your main source for all information, and if you cannot find it on Canvas, you can ask me, for instance, via the chat box. So I guess this is what I wanted to say about the organizational setup. Hopefully this was all clear. If you still have questions, put them in the chat box. I'm going to look at them now during the break. It's 2:15, which means that I've been busy for almost 45 minutes. So we're going to have a 15-minute break. And then I'll get back. I'll deal with the questions that you had in the meantime. And then we'll start with the mathematical topics of week 1. So I hope to see you in a bit. That's it for now. Thank you. So let us start again, and I'll switch on the webcam for a second. So I got some feedback in the chat, and I'll try to answer some of your questions. Also, Olivia told me that she really likes this format, so thank you for the compliments, and I'm glad you enjoy this. Please let me know, others, also what you think. I saw that the numbers were going back. That's really interesting in YouTube. So during the break, we went from 180 to 160, but it's going up again. So we have 172 viewers at this moment in time. That's great fun to see. So a few more questions about the STAR test, and I can imagine that because it's already this Thursday and you've just started. So first of all, it's going to be multiple choice, so you don't have to do any mathematical typewriting there. You just have to pick the correct answer. You won't be able to ask for a different question there. So getting a different question that I just showed you, that's only for the digital tests, basically from week 2 until 7. So those online tests that are linked to in Canvas. There's going to be no proctoring. For the whole course, you don't have to study LaTeX, the mathematical typewriting software. If you're not interested, you don't have to do that. It's nice to know it, but you can always get by without doing that. The homework in the ANS system is new this year. I have been using ANS in previous courses, and normally you can also upload handwritten notes there. So you just make them on paper, take a photo, and you can upload that too. There is a video on doing your homework in ANS by Hans Kuipers. I didn't see that yet, but there he tells you how to use the ANS system for your homework. You can find the video under manuals. So in Canvas for this course, and then in the manuals section, there is a video on doing your homework in ANS. Let's see. Someone said he had the 8th edition of the book. That's really interesting because the 5th edition is the newest. So probably you have a different calculus book. So make sure you have the Smith and Minton book and not the Adams book. So there's also a book on calculus by someone called Adams, but we don't use that. That's the book that is used in variants 2 and 3, not in variant 1. There will be a reset for the STAR test. So the STAR test is the only test, except for the final test, that has a reset. So in week 8, I think it is again on the first day, but you would have to check. In October, there is going to be a reset for the STAR test. So you can do that again. Let's see. I think that answers the questions for now. Yeah. If you have further questions, put them in the chat box. Maybe I'll answer them later, and otherwise I'm going to answer them on Wednesday. There was also a question about getting additional time for dyslexia and so on. I don't know about that. So send an email to calculusabc@tue.nl because I'm not sure what to say there. So let's go back to the slides and let's actually start doing some mathematics now. So this week, it is a bit of background. So preliminaries, a bit on functions. So functions from X to Y, as you know, from mathematics in high school. And a bit on working with functions. Most of this, I think you will already have seen. There may be a few new bits and pieces. So let's see. And this nice cricket that you see here, it will actually be in the questions this week. So what will we cover? We've already seen that before on Canvas, sections 0.1, 0.6 from the book. I will add an application by calculating from Fahrenheit to Celsius, so the temperature scales. As you know, in America, they use Fahrenheit, we use Celsius. And that's related to the cricket chirping rate, so that explains a little bit the title slide. And here you see a few things that we will be dealing with. So some bits you already know and a couple of new bits. These are the topics that we will cover this week, so today and Wednesday. So it says here quotations from an American textbook. That's actually Smith and Minton, but then a previous version. Because in the previous edition they used all these funny American units and now they switched to standard units. But in a previous version, they had this question saying that the chirping rate of a cricket depends on the temperature. So apparently, if it's hot, it chirps more often per minute than when it's a lower temperature. And now if you count how many times a cricket chirps, you can estimate the current temperature, which is quite interesting. I didn't know that before. So here the question is to find a linear function relating temperature to chirping rate, and then this is all in Fahrenheit. Now, when I was first teaching this course, I thought this was really silly that they had a Fahrenheit, so I made a new question from this, which is, the book uses the Fahrenheit scale for temperature, and it's defined like this. Well, this is one way to define it. So water freezes into ice at 32 Fahrenheit. It boils at 212 Fahrenheit. And if you have these two data points, you could ask yourself the following question. So if you know that the scale is linear, then if you know that the average temperature in New York in September is 76 Fahrenheit, what is this in Celsius? The reason I pose this question here is that it's not trivial, but then again, with the mathematics that you know at this moment in time, you should be able to solve this. Not immediately, not by heart, but if you puzzle a little bit about this, you take some pen and paper, hopefully you'll find what the temperature in Celsius is. Hopefully, after the lectures this week, you will do this much faster than you would do it now. So you can try to do it now. And I'm not going to give the solution now, but I'll get back to this on Wednesday. And you can think about it in the meantime with the additional mathematics that I will be dealing with in a second. Also, if you think about it, this question is not very interesting in and of itself. So if you have 76 Fahrenheit and you know what's in Celsius, that's not particularly interesting. We cannot go to New York anyhow at this moment in time. So let's generalize this a little bit, and that makes it a little bit more into mathematics and abstract thinking and so on. So you could formulate the question a little bit more general. So if you denote a temperature in Fahrenheit by TF, so capital T with subscript F, in Celsius by TC, can you then give a relation in general between TC and TF? So I'm not going to do that now, but I will look at this again on Wednesday. So try to think about this before we meet again virtually on Wednesday. First, a little bit about numbers. So, as you can imagine, numbers are very important in mathematics. And sometimes we don't know certain numbers and then we denote them by letters. There was a question in the chat, why do we use letters in mathematics? Well, sometimes we want to say general statements. Like on the previous slide, we denote temperature by T, because we want to say something more general than just one specific temperature. So, natural numbers. Natural numbers, well, you start counting things already as a child, and they're the most simple numbers we can have, where you might argue a little bit what a zero is such a simple number. Sometimes also in textbooks they do not have zero as a natural number, but we'll include it. Now, if you start doing stuff with them, and one moment in time you see that you lack certain numbers. So you would also like to talk about negative numbers. Now, if you take the negative numbers too, so -1, -2, and so on, we denote that in mathematics with Z. And if you do that with handwriting, we have the natural numbers. So you do a double bar on the left to get the N here. And then you can also talk about integers, and you write it like this. And if you think about it, why is that called Z? That's from the German word. So in German, the integers are called Zahlen. So that's written with Z, and that's why we denote integers with Z. Then the next step is that we can talk about quotients, rational numbers. So P over Q, with P and Q both integer numbers, and we cannot have division by 0. You probably remember that. So the Q should be unequal to 0. Now, if you have a rational number, so that's written Q, so now we have N, we have Z, and now we have Q, also written with double bar. If you would write them in a decimal representation, so you put them in a calculator and you see what the decimal representation is, it always starts repeating 4 rational numbers. And then finally, Q does not have all the numbers that you know. So numbers like the square root of 2 or pi or e, the exponential that we will encounter in a few weeks' time, they all have decimal expansions that do not repeat. So they keep changing every time there's different numbers coming there. And they're called irrational numbers. So rational, that's Q. Irrational, that's R. So capital, or well, not capital R, but also R written like this, so with a double bar. Those are basically all numbers. So if you remember from school that you denote all the numbers, you can denote them with a line. So all the numbers on this line, that's this set R. And we already looked a little bit at notation. So you could say that N is a subset of Z is a subset of Q is a subset of the real numbers. So this little symbol here means subset. And basically what it means is that every natural number is also an integer. And every integer is also in the rational numbers. Because if you have, for instance, 5, that's 5 over 1, so that's also in Q. And every rational number is also a real number. So real numbers are all the numbers that we have around us. All the numbers that you encounter, that's denoted with R. And one more thing with notation, what we sometimes write is something like square root of 2 is an element of the real numbers. So this here, a kind of little euro symbol if you like, means is an element of. So it belongs to that set, it is part of that set of numbers. And we sometimes also write something like this. So that means the square root of 2 is not a rational number. So if I write is an element of and then cross it, it means is not an element of. Okay? Very often in many applications we will be working with intervals. So intervals are just two limits, a and b here, on the real line. So here's a number a, here's a number b, and we take all the numbers that are in between them. So what it means here, the interval AB, and if I write square brackets there, so as you can see, these here are square brackets, so like this. It means that the endpoints are included in the interval. So if you write here, these things, these accolades, mean there is a set coming up. Then that set is every real number, every x in R. This here means for which the following condition holds true. So every x in R for which holds true that a less or equal x less or equal b. So a, b, and every number in between. That's what it says here. Now, as you probably recall from mathematics, we can also talk about open intervals. So when I write round normal parentheses here, it means that the endpoints are not part of the interval. So all the numbers in between a and b, but not a and b themselves. And I pictured that here by plotting a little open circle. So the open circle means that a and b are not part of the interval. And you can also mix that. So you can also say a does not belong to the interval and b does belong to the interval, or the other way around. So intervals, very important. We also have unbounded intervals, and maybe you have this notation with little arrows pointing to the left and to the right. Nobody in mathematics uses that. That's only used in high school in the Netherlands. So if you want to talk about all the numbers to the left of a plus a itself, we write it like this. So this symbol here means infinity. So the interval that we have here, this here, is all x in R for which x is less or equal a. A is included because there is a square bracket there. And you see the other versions too. So this one says that a is not in there. This here is every number bigger equal a. And this here is every number bigger than a. So don't use the notation with the arrows. Mathematicians get nervous when you do that. Ooh, inequalities. Okay, before I do that, let's look at a few examples. 1 second. So, as you maybe already have seen, so let's insert a little bit of extra paper for me, like this. Okay. So, example. So the next slide is a little bit theoretical. So I first want to do a couple of examples so you know what I'm talking about. So if you are being asked for all the x's for which this holds true, 2x plus 5 is less than 13. So you probably remember what to do. So you have to subtract 5 on both sides of the equation, which means that you get 2x is less than 8. You can divide by 2. And you see that all x's that satisfy this equation are x less than 4. So solutions, if you want to write them as an interval, are minus infinity up to 4. So those are all the x values that satisfy this inequality. Let's do one more. So let's say that we are interested to find all x's that satisfy this equation. Well, this inequality, I should say, and in fact it's a double inequality because there is 2 of them. I could split them, but let's treat them at the same time. So what I'm going to do is subtract 1 from every term that we see here. So then you get 5 is less than minus 3x is less or equal 9. And now I'm going to divide by minus 3, and hopefully you recall if you divide by a negative number, then the inequality signs, they swap. So I'm going to say 5 over minus 3 is bigger x is bigger equal 9 over minus 3. So that's how you can rewrite this. So if you have a negative coefficient of x, the sign swaps, and I can rewrite this 9 over minus 3, that's minus 3, and I'm going to write that here, and then I'm going to write less or equal x is less than minus 5 over 3. So if I want to write that as an interval, I get the following solutions. All the x's in between minus 3 and minus 3 is included, and minus 5 over 3. So that's how to do these types of inequalities. So now let's go to the bit of a scary slide that I was referring to, because this has a theorem, and this theorem looks a bit, what should I say? It is kind of abstract. It doesn't give much information here. So I try to add in words what it says here. So if you have an inequality, so say we have 2 numbers a and b, and a is less than b, then basically you can add c to both sides of the inequality. C can be a negative number. So if you have a less than b, you can add something as long as you do the same operation on both sides of the equation. That's what it says. Second one, if a is less than b and c is less than d, then a plus c is less than b plus d. So what it says is that if you have 2 inequalities, you can add them. You can add the a and the c together if you also do the same with the b and the d. Okay. Then the last one, and I already used that in the example that I just showed, if you have a positive number, then you can multiply the whole inequality with that. But if you have a negative number, then the sign from here to there, it swaps. So in words, you can multiply with a positive number, divide by a positive number, multiplication, division, it's more or less the same. Eh? Or if you multiply with a negative number, then the sign swaps. Less or equal becomes bigger equal, and bigger becomes smaller. Okay. Fractions. Let's first look at an example again. So, let's see. You've already dealt with those before, but they were a little bit more complicated. So let's see, example. If you have x minus 1 over x plus 2 is bigger equal 0. So this is a bit different from what we've been covering so far. Because, well, if I would like to multiply this thing with x plus 2, well, I don't know whether x plus 2 is positive or negative, so that's not going to work. So the idea that you should have for these types of inequalities is that you should make a sign chart. So what is a sign chart? A sign chart means that I'm going to look what is on the left hand side here, so this thing here, x minus 1, x plus 2. And I'm going to try and study when this is positive, negative, 0, undefined. So in particular, I'm going to check where the numerator is 0. So the numerator, that's x minus 1, is 0 for x equals 1. The denominator, that's x plus 2, is 0 for x equals minus 2. And those are kind of special points in the sense that if this whole expression wants to change sign, wants to go from positive to negative, something can only occur at these 2 points. So if I make a little drawing, and this is a sign chart, then I'm first going to put these special x values here. So x is minus 2 is kind of special, and x is 1 is kind of special. I know that at x is 1, the whole expression, so the whole expression is x minus 1 over x plus 2. So that's at the top of my little drawing. So that is 0 for x equals 1. And it is undefined because I get division by 0 for x equals minus 2. So I write a question mark there because I don't know the value. The thing is not defined there. I could also put infinity or minus infinity, but I just put a question mark because I don't know. Now, the idea is that the whole expression, so this whole thing here that I encircled, is positive or negative or special, and special we already covered, which means that for all the values in between minus 2 and plus 1, it is either plus or minus. And it doesn't change sign there, because if it wants to change from plus to minus, that can only happen at either minus 2 or at plus 1. So what I'm going to do is I'm going to pick a special value in between. Well, special, I pick some value in between minus 2 and plus 1. Let's pick 0 because 0 is easy. For 0, x equals 0. So let's do that in green. Okay. So I'm going to pick here x equals 0. For 0, you see that you get a minus sign. And that means that for all the x values in between minus 2 and plus 1, this is going to be negative. I also want to know what it's to the right of 1. So what I'm going to do here is I'm going to pick 1000. if you plug in 1000, my drawing is not up to scale as you see. If you plug in 1000, you get 999 over 1002. That's positive. So I can now conclude that for every x value to the right of 1, this is going to be plus. And then finally, I also pick minus 1000. So the specific value is not important. I could take minus 5, minus 1 million. But if I put minus 1000, you immediately see that you get something like minus 1000 over something like minus 1000. That's minus over minus, and that's plus. So I'm only interested in the sign. So plus. For every x value to the left of minus 2, I have plus. Okay? So the green stuff that I put in here, you normally don't write that. So you only write the blue stuff. And I can now immediately find the solution here, because you see that for the solution, I want it to be bigger equals 0. That's here the original question, bigger equals 0. So apparently that holds true for x is less than minus 2, or x is bigger equal 1. Because for 1 it equals 0, so 1 is included, that's fine. So if I want to write it in terms of intervals, I have minus infinity, comma, minus 2, open, union, 1 to infinity. And let's do that in red here. This symbol that I just wrote means union, and that means that I take one set of numbers, one interval, I take the other interval and I put them together. So I unite them. So this is the symbol that you use for that. Both of these two sets together. Well, let's do one more of these, because you get a number of them in several questions. So I'm going to do one more example. Example. So I'm going to try and solve 6 over x minus 3 is less or equal 3 over x minus 5. Now, if there would be an equal sign, so I now have this less or equal thingy. If there would be an equal sign, you could do cross multiplication, right? You do 6 times x minus 5 equals then 3 times x minus 3. You cannot do that here, because we don't know the sign of x minus 3. Is it positive? Is it negative? Also the sign of x minus 5, we haven't got a clue. So the way to do this is move everything to the left side. So 6 over x minus 3 minus 3 over x minus 5 is less or equal 0. So that's the first step. We want 0 in the right side of the equation. We move everything to the left. Next, I'm going to give them the same denominator, because I want to take these two terms together. So then I get 6 times x minus 5 minus 3 times x minus 3 over x minus 3 times x minus 5 is less or equal 0. And now, of course, I can rewrite this a little bit, but basically we're back to the previous example. Because now we have, let's do that, 6 times x minus 30 minus 3x plus 9 over, this one I'm happy with, I'm just going to leave that like this, less or equal 0. 6 times x minus 3 times x, that's 3x minus 30 plus 9 minus 21. X minus 3, x minus 5 is less or equal 0. And now what I'm going to do is make a sign chart. This is just like the previous example. So let's draw a little vertical line here. I'm going to build a sign chart. Sign chart. So here I'm going to put x. Up here I'm going to put the whole thingy, 3x minus 21 over x minus 3, x minus 5. So what are the special points? Well, the denominator equals 0, 4, 3 and 5. So there, this expression has a question mark. I don't know what the sign is. Then the numerator is going to be 0, 4x equals 7. So there it equals 0. Now, next to find the plus and minus, we're going to work like before. So to the right of 7, I'm not going to put down the green values now, but let's write them below here, because normally you do them on scratch paper, you don't write them. So here I pick 1000. Why 1000? Because I immediately see that I get plus over plus times plus. So the whole thing is going to be plus. Then in between 5 and 7, I take 6. And then I get 3 times 6 minus 21. So I get minus over plus times plus. So the whole thing is going to be negative. Oops, I should write this thing here. 1 second. I want this to be blue. So this was plus. For x equals 6, and so every value in between 5 and 7 is going to be negative. Here we can pick 4, and then we get negative over plus times negative. So this is going to be plus altogether. And I could pick here all the way to the left, I could pick 0. And if you pick x equals 0, you get minus over minus times minus, and the whole thing is going to be negative. So finally, read of the solution. What did we need? We needed the whole thing, so the original question basically was less or equal 0. So if you now look at the sign chart, then we see that the solution is minus infinity, comma 3, union with 5, 7, and 7 is included, because at 7 it is 0. So that's how to do these types of questions. So now let's go to the slide that I skipped earlier. So if you have an inequality with fractions, that's the examples I just covered, you find the zeros of the numerator, you find the zeros of the denominator, and then you make a sign chart and you read of the solution. So that's the general way to do that. And this is something that many students make mistakes with, because they want to go and multiply with denominators and stuff like that, but that doesn't work if you have inequalities. Okay. Next topic is the absolute value of a function. So the absolute value, you have already seen that function before. The absolute value of x is x itself if you have a non-negative number, if you have a positive number or 0, and it is minus x if you have a negative number. So to the right you see the graph. So it's like here it is to the right, this part here is basically y equals x. And here on the left for negative x, it runs like y equals minus x. And you can interpret this as the distance of a point to 0. And since it's a distance, the absolute value is non-negative. So properties, if you have two numbers, then the absolute value of AB is absolute value of A times absolute value of B. And you can also show that if you have two numbers, then the absolute value of a plus b is less or equal absolute value a plus absolute value b. I assume you've seen this before, so I'm not going to spend a lot of words on that. One thing, if you have something like absolute value of x is less or equal r, you can split it into two inequalities. It means that x itself is in between minus r and plus r. Okay. As an example of this latter thing, so if you have the inequality x plus 4 absolute value is less or equal 7, then you can solve that using this rule. So you get minus 7 is less or equal x plus 4 is less or equal 7. And then it's like before, you subtract 4 from all terms, minus 11 less or equal x less or equal 3. So you see that the solutions are all x in the interval from minus 11 up to 3. You can get kind of nasty inequalities with the absolute value. So here is one of those. So it says find all x values for which 5x minus 4 absolute value is less than 3x minus 4 absolute value. And if you don't know how to do this, they can be kind of tricky. Maybe you know that there is a website called Stack Exchange where you can ask questions on a variety of topics. And I think I took this example from math.stackexchange or math.exchange. I'm not sure what the link is. But anyway, people asked about this question on the internet. So if you don't know how to do this, they can be kind of tricky. If you do know how to do this, they're not that difficult. So the way it works is just following what we did before. So first we move everything to one side of the equation so that we get a 0 in the right-hand side. Then we are first going to see where this thing equals 0. So if this whole expression needs to be 0, it means that 5x minus 4 absolute value needs to equal 3x minus 4. That gives two separate equations. So this thing here, I saw a question about that in the chat before, that means OR. So before, when I was showing a demo, I had this thing which was AND. And this is mathematical shortcut, mathematical symbol for OR. Now, if you solve these two equations, you see that you get x equals 0 or x equals 1. Those are the two solutions if you have a equals 0 in the right-hand side. And now we make a sign chart. So what we do is we make a sign chart where we put x below and the special values are 0 and 1. So that's basically the values where it can change sign, where it can go from plus to minus or the other way around. And up here we put this thing, 5x minus 4 absolute value minus 3x minus 4 absolute value. We pick nice values, for instance 1000 here to the right and minus 1000 here to the left and maybe 1/2 in between. And if you do that, you get plus minus plus. I trust you can do it by now. So then we can read off the solution and we're done. So apparently for x values in between 0 and 1, this inequality holds true. So that's how to deal with these inequalities. Okay. So the next bit is distance between points. So if you pick 2 points in space and you want to know what the distance is, well, you probably know how to do that. It's basically the Pythagoras theorem. So if you have 2 points and here their general coordinates x1, y1 and x2, y2, then this is the distance. Well, that's just a formula. How can you derive that? Well, just make this picture. So I have a point P, I have a point Q. P has coordinates x1, y1. The Q has coordinates x2 and y2. And you see here that you get a nice triangle. It's a triangle with a 90-degree angle. So using Pythagoras, we see that the distance here, the distance between those 2 points can be found from the triangle. So that is where the formula here in the blue box comes from. Take the square root and you have the distance in between the 2 points. Okay. So the next topic, and that is related to the question that I started with today, so the temperature question and the cricket question, which you will find in the homework, that is about straight lines. So if you are in the plane, so here we have an x-axis, here we have a y-axis, and if you take 2 points, P and Q, just like before, you know that there is exactly one straight line that goes through these 2 points. If you have 2 separate points, there is precisely one straight line that goes through them. So can we find the formula that belongs to this straight line? Well, first, the slope, in Dutch language, richtingscoëfficiënt, or maybe hellingsgetal, depending a little bit on the mathematical textbook that you used in class, that is delta y over delta x. So that measures how fast the line is going up or going down. If m is positive, the line goes up. If m is negative, the line goes down. If m equals 0, we have a horizontal line. So difference of the y coordinates over difference of the x coordinates. That's the slope of the line. So the general form of a straight line, if you have a straight line with slope m, is y is m times x plus b. So there's 2 constants in there, the m and the b. If you want to have a line with slope m that goes through a certain point x1, y1, then this is the formula for it. You can easily find that from the top blue box by substituting y is y1, x is x1. Now, if you have 2 lines, L1 and L2, with slopes M1 and M2, then if they are parallel, and parallel is precisely what you think it means, so if you have a line and you have a second line, it means that they go both like this. If M is the same, they need not be the same line, but at least they're parallel. That means if M1 equals M2. If you want to know what the relation is if they make a 90-degree angle, so like this, then, well, if you puzzle a little bit, then maybe you could draw x and y axis, and you can draw a line like this, and then the line orthogonal to it or perpendicular to it is this one here. So they make a 90-degree angle. So we have, this is L1, this is L2. Now, if you think a little bit about this, then if you have the line y equals x, so the line that makes a 45 degree, then the one perpendicular to it is y is minus x. So y equals x, y equals minus x, they are perpendicular. Then you might be tempted to think that you should put a minus sign in front of the slope. That's not entirely true. Because if you have, for instance, the line y equals 2x, then the line orthogonal to it is minus 1/2 x. So that's an easy example that you can easily draw and how you can remember the rule. Because the rule is this. The rule is that they are perpendicular. If you multiply m1 and m2, you get minus 1. Okay. Now I think that this would be a great point for me to quit for today. And then we have a little bit of stuff left for Wednesday. So as you probably have seen in the planning, it says that on Monday we do theory, on Wednesday we do questions. I try to distribute the theory a little bit over both Monday and Wednesday, but I'll prioritize your questions. So if you have any questions, either put them in the chat box on YouTube or put them on Canvas. So I've shown you in the first lecture hour where you can find that in Canvas. And as I said, you can also email me. So if you prefer to write it down on paper and take a photo, just send me the photo. That's also very easy for me to deal with. and I can also put them in the lectures. If you want to give any feedback, like Olivia already did, do you like this? Do you think I should do it otherwise? Do you think I should be doing more questions here? Let me know. Is this doable? And I hope to see you all again on Wednesday morning. So bye for now, and I'll see you in the next lecture. Thank you very much.